slides and notebook prepared for week 7 covering the topic. So now of the points is what will be
By drawing daily sketches, you can develop discipline, improve your skills, and foster new ideas. It serves.
Hello everyone. In this video we are going and of those points the label corresponding to the majority of the all other points, depending on the value of k, we are going to assign a label to this point. Consider the case of k equal to 6. So for k equal to k, let us try to assign a label in this classification algorithm, and this value of k is in practice is k is a hyperparameter, and one way to identify a good value of k is through cross validation. Now we are going to have a look at decision trees. First, let us go. Formula for entropy is shown here, the formula for information gain is shown here. We want to find the question S. The value for S can be 1.5, 2.5, 3.5, that is 1.5, 2.5, 3.5, 5 and so on, and the information gain belonging to class 1, these points here, which is why the proportion value is 0.97 and to class 0 on one side and points belonging to class 1 on the other side. That is, they are going to entropy, and likewise for the right, the green and 0 red points, and 0 green points here and 5 red points here. The proportion of points again is set. Once we have found that, same function here, and
what is the best question to ask, and it is only for that free or independent parameters will the model have? So this is 9 other boxes here, right? So this, right? So in this case, the vocabulary is going to be the words 1 to 9 and 0. There is no label, so you're only modeling p of x. Okay. Now, what generative models try to do is
it belongs to.
Yeah. So we are trying to learn a generative model, right? In this case, right? I can't stop. I can't say that I'm only going to flip 1, 5, and 8th coin. Okay, that it doesn't work that way. So I got this 1, 5, 8 only after flipping 10 coins.
Sir, can you explain this data generation process? Means I'm not.
And that we are making is of this kind, where we say that
X1 and all that, right? So all other
24th parameter can be obtained from the remaining
1 - 1043.
Yeah. So that is why there are. So this is number of free or independent parameters. This is for each class, right? Therefore, you have to multiply by 2 for the 2 classes. So that's how you get this. So if you generalize this, it is number of classes into total number of parameters for one class. That is 2 power number of features minus 1. This is only for binary features, by the way. And if that is classes, you need only one parameter. So if there are 3 classes, you need 2 parameters and so on.
So that
Okay,
can be, if it is a multi-level, then you will get more than one. Otherwise, it is one always.
Yeah. Okay, so this is, I hope this is this formula clear to everyone. Okay, so this is for when the class conditional independence is suspended, that assumption is suspended. Naive.
Go back to the earlier slide.
Yeah.
Yeah, just
You have 3 kinds of symbols that I'll be using. This P denotes the probability, the prior probability, right? So y into P of x given y. That's what we have written here. Okay, so things that have
Particular word appearing.
Yeah, so every training data point in class 0 has 4 appearing in it, right? So if you go back, right, yeah. And it is given by this value. The rest of them will go into B. That is linear discriminant analysis or Gaussian naive Bayes as
the maximum likelihood estimator technique, right? So yeah, and whatever we are speaking right now, these 3 algorithms, which is k nearest neighbor, another one is decision tree, and the third one is the naive Bayes. Let's say, what about these techniques? They are the supervised learning techniques, but we have the corresponding label, right? Correct. So in the during training, I know that it will be a tie, right? So that means we don't know. So in the tie case, what should be the prediction? It can either be negative class or it can be a positive class, right? If I have the 4 nearest neighbor. Yeah, I understand, but it is given in the question that the test point is classified as red with k equals to 4. So I know this is the red class. Okay. Using the okay, am I audible? Yeah. Okay. P is half, then 1 minus p will be again it's half, right? So this set or a pure data set by looking at this correct direction. Is that correct? Let's say because these are the positive classes and the data set, the number of values in the sample or this data set, if they go A decision stump is a decision tree that has exactly one question at the parent node, which then splits into two prediction nodes. Okay. Consider a decision stump. Similarly, the entropy one, or actually, it is not necessary, right? Yeah, it is not, because these are like two separate things. They might have their own probabilities, and
Success.
successes in sample. Denominators are the same on the both side. If I ignore this denominator while comparing, yeah, two. So we need two parameters for the classes, and X transpose inverse. This is the vector, right?
On my hello. Hello. Good evening, everyone. Am I audible? Okay. Good evening, everyone. Am I audible? Everyone? Okay. Good evening, everyone. Am I audible? Hello.
Hello.
Yes, you're audible.
Audible.
Okay. And my screen is responsive, right?
Yes.
Okay. So today we will discuss the previous year question. Previous year question is in last 3 terms question from quiz 2 that are asked from week 5 and 6. Yesterday it was our like week 5 and 6 revision session. Today it's week 5 and 6 PYQ session. Tomorrow is week 7 and 8 PYQ session, and after tomorrow is week 7 8 revision session. Okay. I have shared the like schedule for the this week in a Discourse post, and I have shared the link of the post here in the comment section. You can go to that, and the session like okay meet link you will get in your calendar. Okay. Okay. Everyone clear? Okay. Okay. The syllabus for quiz 2 is entirely with 5 to 8. There will be no question asked from week 1 to 4. Okay.
Sir, your voice was cracking. Can you please repeat what you said?
I was saying the syllabus for quiz 2 is entirely with 5 to 8. No question will be asked from week 1 to 4. Okay, and I'm facing a little bit like network connectivity issue. If like I like disconnect or like if you guys are not able to hear or see my screen properly, just let me know. Okay. Okay. So today we'll follow that. Like I'll give you the question and I'll give you some time to solve. First, all of you try to solve the question alongside. Just keep your notebook and pen ready. We'll solve the question. Most of the question are conceptual, few are calculative, and then we will move to the solution. Okay. Okay. Let's start with the first question. This is from January 2024 term, quiz 2. Okay. Consider a dilemma where you are tasked with predicting the sales price of house based on their square footage. Okay, so our feature is only one, that is based on their square footage. You decide to experiment with 2 different models. The training dataset consists of information on 200 houses. The number of samples in our training dataset is 200, and you use the models to make prediction on a test dataset of 50 houses. Okay, the mean square error is chosen as the evaluation metric based on the above data. Okay, consider the given subquestion. This is the model P where y hat is equal to w0 plus w1x, and this is the model Q where y hat is equal to w0 plus w1x plus w2x square. So the first question is that, considering the specific context of predicting house prices based on square footage, which model is more likely to provide accurate prediction on the training set? The first one, the options are model P, model Q. Both the models are equally likely to provide accurate prediction, and it depends on the distribution of house prices in the dataset. Take your time and solve this one. These are 2 models. We have 200 data points.
Sir.
Yes, we build our model using training dataset, and then we validate or we test our model using the test dataset. Okay.
Here it is written provide accurate predictions on the training data set.
Okay, consider the specific context of predicting house price. Which model is more likely to provide accurate prediction on the test? Okay, that might be an issue. Provide prediction on the training height to the test dataset. Okay. First option is model P, that is this one. Then model Q. Then both model distribution of the house price in the dataset. First of all, tell me, does it depend upon the distribution of the house price in the dataset?
No.
Okay, because our features is like based on the square footage, right?
Yes.
Okay, so this option automatically cancels out. Out of this 3-1, can these 2 model like produce exactly same same or accurate output, accurate prediction?
No.
Okay, so this also cancels out. So out of these 2, which has like higher chances of predicting accurate house prices?
But in this question, what accuracy means? What accurate predictions?
By accuracy we can mean like we have built our model using train set, right? Then we have let's say we have 50 test set, and out of this 50 test set we like bring out one data sample, like one sample of data or one data set, and then we put that into the model, and the prediction that will be produced by the model out of these 2 models, which will like will be able to predict the better price.
So we are giving the prediction on test data set, right? Not training.
This will be test data set.
Okay. So sample size is small. So model Q, I think will give more accurate
Others?
prediction.
Okay, others, do you agree?
Yes, sir, because that will result in a higher reduction of the error.
Yes, sir, model Q because of the W2x square value.
Okay. Let's move into the
Quadratic.
Model P is a simpler linear model with only 2 parameters, right? W0 and W1. And model Q is more complex with 3 parameters, W0, W1, W2. W0, W1, W2. Okay. A complex model, model Q generally has greater flexibility closely compared to the simpler model, model P. Okay. This is because model Q can capture both linear and quadratic pattern. This will capture your linear pattern, and this X square. This term will capture your quadratic pattern, right? Yes. whereas model P can only capture linear trends. Therefore, model Q is more likely to provide accurate prediction on the training data set because it has greater flexibility to feed the data. It will be test data set because it has greater flexibility to feed the data. Okay.
Yeah.
Test.
These questions are picked up from you, right? I mean, by previous 3 terms.
Yes, yes. All the questions from the last 3 times that were asked, I have picked all the questions.
So, is there any way to access these questions after the session?
Yes, this document I will share in the Discord, this entire solution document along with question. And this question you can go to quizpractice.space from there. Let me paste the link for it.
Yeah, that is okay.
I have more because after I get the session after session recording and I post that by most probably by tonight or late in the night or tomorrow morning. Okay.
So I have one question on this. Like people were confused whether it was asking for training prediction on training data set or test data set. So even if we were supposed to predict on the training data set, it would not have made any difference, right? I mean,
yes, it wouldn't have made any difference. But in general, what we do in general, we build our model using training data set, right? Like in anywhere in the application, and then it is not like it doesn't produce anything good if we again check our model on. So in general, we usually see our data like our model on unseen data set that we call as test data set, right?
Right. So even if we are asked just in case that we have to predict on the training data set itself.
Okay, this is the sub question of this one only. Like this is the main question, this is one sub question, and this is another sub question. Okay. Identify the factor that could influence the model performance on training data set in this housing price prediction scenario. Select all correct statement. Model P may struggle to capture non-linear relationship present in the house price data. Second question is model Q might be sensitive to outliers in the square footage variable. Okay. The choice between model P and model Q depends upon the budget constraint of the potential home buyers, and model Q will always perform well on the test data set. Okay. So among all of this one seems like little vague because the choice between model P and model Q depends upon the budget constraint of the potential home buyer. Do you think this is correct?
No.
This is anyway not going to be true, right? Now among A, B, and D, which one or 2 or 3? This is MSQ. So A on the one's variable. Okay. Identify the factor that could influence the model performance on training data set in this housing price prediction scenario. Select all correct statement. Model P may struggle to capture non-linear relationship present in the house price data. Second question is model Q might be sensitive to outliers in the square footage variable. Okay. The choice between model P and model Q depends upon the budget constraint of the potential home buyers, and model Q will always perform well on the test data set. Okay. So among all of this one seems like little vague because the choice between model P and model Q depends upon the budget constraint of the potential home buyer. Do you think this is correct?
No.
This is anyway not going to be true, right? Now among A, B, and D, which one or 2 or 3? This is MSQ. So more than one question can be correct. Okay, so I am observing many A and B. Okay. Model P may struggle to capture non-linear relationship present in the house price because it is just a simple linear model, right? Model Q has your square term, so it will be able to capture a good way. Like it will be more than one question can be correct. Fourth, depends upon the budget constraint of the potential on the one is variable. Okay. The choice between model P and model Q depends upon the budget constraint of the potential home buyers, and model Q will always perform well on the test data set. Okay. So among all of this one seems like little vague because the choice between model P and model Q depends upon the budget constraint of the potential home buyer. Do you think this is correct?
No.
This is anyway not going to be true, right? Now among A, B, and D, which one or 2 or 3? This is MSQ. So more than one question can be correct. Okay, so I am observing many A and B. Okay. Non-linear relationship present in the house price because it has your square term, so it will be able to capture a good way. Like it will be able to capture better non-linear relationship, right? So this one is true. All of you agree?
Yes, sir.
Sir, the option has been phrased incorrectly.
How is this, sir?
Sir, the first option, because it says that model P may struggle to capture the non-linear relationship. It should have been that model P will struggle to capture because like it's not a probability, it's a certain event because it's a linear model, right?
No, we haven't. No. We haven't seen the data, right? We don't know. It may or it might not. We only know that we have only 200. We don't know the exact data points. So it may or it might not also be possible, right?
No, sir. Here they are saying that if there are any like non-linear relationship present in the house price data, in that case, the model P may struggle to capture it. But sir, like there is no possibility that it will correctly capture it, right? Because it's a linear data set. It's a linear model. Sorry.
So it's a grammatical error or not, I cannot comment on that part, but this option is false because this we know P is a linear model and it may struggle to capture. You are correct in your way, like it will struggle to capture, but this thing I am not able to like comment with 100% surety that model P will struggle to capture non-linear relationship present in the house price data.
So sir, here we'll treat it as correct.
Yes.
Okay.
So option D is not correct.
Yes, option D is not correct because it has like it will always they have mentioned, right? it might perform better than model P, but always it will perform well on the test dataset. It is not possible. Let's say if we have like cubic relationship in our dataset, it will not be able to like perform that well on our test dataset, right?
Sorry, sir, I didn't get you.
Let's say we have our cubic relationship or some fourth power relationship in our like test dataset. So in that case, model Q will not always be like able to perform well on the test dataset, right?
Yeah, but how are we so sure that I mean we are getting these
Because no, this thing model Q will,
terms.
they have mentioned that always perform well. It is even the bestest of bestest algorithm cannot like make a model that will always predict well or perform well on test dataset, right? So this the main issue is this always. The model Q will always perform well on this test dataset. This is not possible.
So what about option B? How it is sensitive to outliers?
Okay, model Q might be sensitive to the outliers in the square footage variable. Okay, we'll see the this model Q includes quadratic term which can amplify the effect of outliers in the square footage variable. This makes it more sensitive to outliers compared to model P. Okay, so this option A and B are correct. Okay.
Model P is a linear regression model and cannot account for nonlinear patterns.
In the data, if house price have nonlinear relationship with square footage, model P will struggle to feed the training data properly. Model Q includes quadratic term, that is x square, which will help like it take more sensitive outliers to compare to model P. Okay, the model of the choice of model depends on the ability to capture relationship in the data and not on external factors like budget constraints. Okay, and the model Q may feed the training data better due to its flexibility. Overfitting could cause poor generalization to unseen data. It is not guaranteed that model Q will always perform well on the test data. Okay. Okay, so kernel regression with the next question from the same set of the question. Kernel regression with a polynomial kernel of degree 3 is applied on a data set. Let the weight vector given by W is equal to alpha x multiplied with 2.3 minus 1.0, 0.4 minus 0.7. Okay, here alpha, here phi x is the transformation. Here phi x is the transformed matrix whose ith column is phi xi. What will be the prediction for the data point 0, 0, 0, 0? This thing you have to directly apply formula that was taught in the lecture, like prediction for kernel regression, something like that. Just try it out.
So I mean that like if we make slight changes to the databases, then the resulting model and its graph would be more different.
Okay.
So like variance in
Because according to the like the given model, if we change our data set, right?
okay, sir.
Okay, I can say many answer as one. Okay, 1. Okay, let's move toward the solution. Okay, tap of xi, comma x test. Okay. K of kernel regression of 3 polynomial plus 1 to the power p, and here x transpose x in that with respect to y in week 2, right? And to the power p. So here we have here it is mentioned of degree 3. So it is x transpose x test.
But we are just given the degree 3.
Yes, polynomial kernel of degree 3, and we know polynomial kernel is of the form x transpose x plus 1 to the power p, and here the p is mentioned as 3.
Okay.
Okay, this thing this is taught in week 2, right?
So here, if the data point was not 0, 0, 0, 0, then we would require that x also to calculate the kernel,
Yes.
right?
Yes, that's
Here,
why
because it is 0, 0, we don't require the x.
yes. Okay, because anything x can be anything. If we multiply that with x test, I be anything multiplied to 0 plus 1 cube, it is coming out to be 1. Again, x test, if we actually have to, if it is like 0, 0, 1 or something is there instead of 0, we have to actually know this x matrix, right? This x. Clear?
Yes.
But
Because
sir, what is x test?
x the data point. This is our test data point.
And what is X transpose?
X transpose is our any X value. Like we have a matrix given as X. That is actually, if we multiply anything with that column of this matrix, multiply to 0, it is coming out to be 0, right? So Siddharth told that thing only. If these prediction points are not 0, then we had to know the actual value of X to calculate this solution. Okay. Since anything, let's say X has any value, if ultimately we are multiplying that to 0, so it is coming out to be 0, right?
Okay.
Yeah, you are getting how it is 0, like how this
Yeah,
part is actually
so we can
any
assume
value.
we can
Yes,
assume X to be any value.
yes, any
But
value
it's
of
not
X.
given, right?
Yes, any value of X multiplied with 0, it is coming to be 0 plus 1 cube. So it is 1 cube is 1. So for there are four data points are there. So it will be this matrix 5x will be your 1 1 1 1. This up to this part clear? Okay. Now we'll put that into our formula. This formula. We know our 5x and this is given to us. We know this 5x and this is given to us, right? We know our 5x and this is given to us. So now we'll do this alpha star is given to us. Okay.
What is alpha star, sir?
This is the alpha star. The formula for calculating alpha star is your k inverse y. Okay. And how we calculate k? Anyone?
K will be calculated as X6 transpose inverse times
We
XY.
just use the polynomial kernel of degree 3. So you just calculate the k using the kernel.
We can calculate, but in general we have X matrix given and we want to calculate the alpha star. How will you do that?
X transpose will be K.
It will be X transpose X. It will be
X into X transpose inverse times XY.
No. It will be X transpose X.
How? But we aren't we given the Y?
Let me show you how. Oh, wait. This derivation is done in lecture.
Polynomial kernel it is mentioned, sir, of degree 3. So you can use that to calculate the kernel matrix.
We can do that, but I am telling in general case because going forward we'll see this kind of question is there that we have given this, let's say this X matrix on this K, this alpha star. We have to do K inverse Y, right? And this K is nothing but your X transpose X.
What is K?
X transpose X.
In this case, it will be 5x transpose 5x.
Yes.
It will be 5x transpose 5x. K will be.
Yes. Because after finding the value of K,
And 5x will be a vector containing all the cubic elements and all the elements.
Like
Yes,
in general, you can say transformed elements. Yes.
Yes.
Okay, instead of making this complicated, when we will y is the level regression problem, we will have our x as the data point and y is the level.
Okay, but in our current question, it's not required to.
Yes. Yes, it is not required.
I mean,
that's why instead of making
this is you're telling in general.
In general,
if you are given X data set and the actual values and so, then we can calculate K as this formula, right?
Yes. We will calculate alpha star by calculating K and then find its inverse and then y. Okay, we'll encounter a question like this today only, and then we'll again come to this and discuss. Instead of making now this question difficult, we'll encounter when we'll encounter the question, we'll discuss that. Okay, so this is just this we find out our K matrix this and our answer is given to us. So this is just dot product. 1 into 2.3, 1 into minus 1, 1 into 0.4, 1 into minus 0.7. So it came out to 1. Yeah. And this kind of question are important. You should practice them because I guess they are in graded assignment also, the same kind of question, and there is high probability that this kind of question might be asked in exam. So you should practice them. Okay. This one. This is a conceptual question. Let X be the data matrix of shape D cross M and Y be the corresponding level vector. A linear regression model of the form Y hat is equal to W transpose X it feet using the squared error on the same data set. If the solution W star to the optimization problem is orthogonal to the subspace spanned by the data point column matrix of what will be the squared error? You just this is a conceptual question. Read this part again. Okay. Okay. This is option C. Others just to read it and try to solve. Let X be a data matrix of shape D cross M. Okay, and Y be the corresponding level vector. A linear regression model of the form Wi is equal to W transpose Xi is fit using the squared error on the same data set. If the solution to W star to the subspace spanned of the data points, like the data points are the columns of matrix X, what will be the squared error? So you have to find the squared error. Siddharth, can you mute yourself? Like some noise is coming from your mic. Okay, thank you. We are given a data matrix of data matrix X of shape D cross N and a corresponding label vector Y, a linear regression model of the form Y is equal to W transpose X. This is given. This information is given in our question. Okay. This linear regression model is fit using the squared error on the same data set. The solution W star to the optimization problem is orthogonal to the subspace spanned by the data set. Okay, is orthogonal to the subspace spanned by the data points, that is columns of matrix X. This is the question that I have, the Y actually found by the minimizing this quantity L2 norm square Y minus W, X transpose W. Clear?
Sir,
Of X. So this quantity is your projection. Realize that the projection of Y onto the column space of X is 0. This quantity is nothing since it is the projection, and the projection, we know the projection is always 0, right? The dot product, it came out to be 0, right? Clear this part?
no, that is not clear. Can you repeat it? No, that is not clear.
Okay. Read again. I am reading this part again. Okay. The solution W star to the optimum vector. So this is the data points, and give the if the solution to the optimization problem is orthogonal to the subspace spanned by the data points, that is columns of matrix X. So this is actually your X transpose. These data points are your X transpose, and this solution W star is is orthogonal to that subspace. So that's the reason this quantity is 0. Okay.
Yeah.
Okay. This is given in the question.
Okay.
Okay. So we have solved the question from January 2024 term. Now we'll go to the May 2024 term quiz 2. Okay.
Sir, this is option C, right?
Yes, this is option C. Whenever something will be given in the question, or you will see in the question paper some words, some information, just try to write the formula, whatever you can remember. Just try to write that in your pen and paper, and then try to think. Okay, then like if you have written this one, then I believe you have solved half of the question. And if you are able to recall like, oh, how this, like what does this orthogonal mean and all, so you can easily able to see that orthogonal mean this part is anyways going to be 0. So this is your L2 norm square, L2 norm Y, like Y norm square, right? Okay. Okay. So this is a question. This kind of question is even asked in this year GATE paper, GATE data science paper. Same kind of question with different values. Consider the linear regression problem with this is our data set X, and this is our label. Okay. Find the optimal W star. Find the value of W star. That is the optimal weight. How will you find that if we know this one? If we know the data point and the label? Anyone?
You need to find the XX transpose. And then
yes. And what does that equation known as XX transpose pseudo inverse XY?
This is one feature, so we can directly calculate it by XIYA divided by XI square.
It's never going to be the case that we are going to find
can you explain?
1 or 2 points short of it. This is more like a rule, not really exactly a rule. That. Let's say if there was a class of 100 people, and then I write a weight and write
Oh, sure. It's a single feature has been given, so directly we can find that sigma of XIYA divided by sigma of XI square.
Yes. Equation as well.
Can you show the question? Your question is not visible. Voice is not audible.
Hello.
Voice is breaking, sir.
Okay.
Hello.
Is my screen visible and am I audible clearly now?
Yes.
Okay.
Yes. No.
So you can use that approach. Okay. And
Which is
don't try
the easy
to.
way, sir?
Huh?
Which is the easy way to solve these questions?
It depends. It depends upon whatever approach you have been practicing since last time. Like it depends upon it. That's the thing I am telling, that during exam time, don't change your approach, like solving of a particular question. You know one type of approach, and if it is little bit hard, but you are good with it, so you should solve that using that one only. Okay. So that summation of x in XIYA by summation of x square, that is possible only for your case of single, like only one feature is here, right, in xi. So that's possible. And another is that your xx transpose pseudo inverse xy. So my question was, what does this equation known as xx transpose pseudo inverse xy? There is some name associated with it.
Normal equation.
Yes.
No, regression equation.
That xx transpose pseudo inverse xy is known as your
Least known solution.
Your voice is not. Hello.
Hello, I was telling that x stands for pseudo inverse. I am telling, but in our course we are considering only the inverse, not the pseudo inverse. Okay, so you should like if anywhere it mentioned not the pseudo inverse, the inverse. Okay, so this x stands for pseudo
Your
inverse.
voice is breaking. I think you are out of network. Your network is not so good.
What you said about the equation name, sir?
Wait. Let me connect to different network. Okay, so I was saying that this x transpose pseudo inverse xy is known as your normal equation, and we can use that one to solve our like find the optimal value of w star. Okay, we can use that normal equation to solve it.
Sir, if the x transpose is not invertible, then how do we calculate the pseudo inverse?
That's the reason I am telling that in course we are considering the pseudo inverse as inverse only. Any matrix you will be getting answer, you can convert that into inverse and do your calculation.
Okay. So taking the inverse means the reciprocal of the matrix, right?
Just in general, you have to find any matrix.
Sir, your voice is breaking a lot now.
I changed the network still. Hello.
Hello.
Is it good now? In general, we have learned that in maths too, right? Given a matrix A, how we found its like inverse, like a matrix is there A, and we have to find it inverse. First, we calculate its like minor factors, cofactor, and then we calculate cofactor, then we transpose it, and then divide it by the determinant of this matrix A. That way, we find the
same process we have to.
Yes, but generally it is not asked in the exam, but you have to know the. Still, one question asked in the lesson only, so we'll go
like
that using like your minor.
For the elements and then divide it. Like we don't have to remember all those steps.
Okay, actually I don't know the method. Okay, we'll look into it. Okay, when we'll go to the question, there is a question for calculating 3 by like the inverse of a 3 by 3 matrix. When we'll go to that question, at that time you can show us, okay, how to calculate it one.
Done, sir. Okay.
So
the solution what we have approached used.
I have approached
the solution. Yeah, sorry, continue.
Okay, there is too much network issues I'm facing. I don't know what to do. Okay, just try to find this one. Okay, I guess many of all of you have done this till now. 0.7.
You don't.
I told you, there are many methods to solve a single type of question. So you can use okay, x is given to us. Then okay, then x trans. This is x transpose. This focus 1 by 10 product, and then we'll write that together. That 1 by 10 into 7.330. Moving to the next question. Consider the following data set for a kernel regression.
Question is not visible. Question is not visible, sir. It's not visible.
Okay. So consider the following data set for a kernel regression problem.
Sir, excuse me, sir. Yes, sir. In the previous question, when we calculate the x into x transpose, we usually take like x to be the vertical representation of the vector, right?
X is of the form d cross n.
Horizontal. It's horizontal. X is horizontal. X transpose is vertical.
We take d cross n, right? In this course, we are taking x as d cross n and y as n cross 1.
Okay.
This is consistent through the entire like course, like from week 1 to week 12. X matrix is always d cross n, and y is always of shape n cross 1.
Actually, sir, I got confused because there was a question in the solve with us of one of the weeks. In that, they had taken the opposite approach.
So that depends upon those who have created the question, but I actually don't know.
Yes, sir, maybe that's one.
So in general, whenever you find, just remember x is always like from PCA, starting from PCA until like from your last SBM and all, your x is always of the shape d cross n and y is of the shape n cross 1. Okay,
sir. Yes, sir.
Consider the following dataset for kernel regression with the polynomial kernel. Here here you can see what's the kernel given to us, polynomial kernel, polynomial kernel of degree 2. So what will be the like formula for polynomial kernel?
It is visible.
Wait, okay. Let me change the position so that the network is better. The direction of the gradient. This is in the direction of the gradient at this point. Okay. Now e plus 1 is equal to w. Will it be w2 or it will be w3? So according to you, Manan, what could be the possible answer?
Help me the question.
This one, this part, right? W1 is of gradient.
Okay.
So
Nice.
here it is given wk. So what is this?
No question was gradient or gradient
Of the gradient. Okay. So here we are given the value of the wt. This wt is given to us. Now you just find this one. Okay, just write down this formula, write down this update rule in your notebook, and then look at this value. Okay, first write this down. Let me know if all of t plus eta.
I'm having trouble studying, and I will be ending this stream because I have to read all that. It is lacking. I can't afford that. I have less time, so I will be ending it so that I can have entire data